Okay, so in our resources, we don't have videos for graphs of quadratic functions. And so we have two objectives in there: write an equation with a quadratic function given the vertex and the point on a graph. And then there's the second one of write an equation of a quadratic function given intercepts on a graph. I'm going to do the one with the vertex and a point. Okay, so first thing I'm going to do is I'm going to go to this um, the book, and it says given a graph on a function, write the equation of the function in general. Okay, so the first thing is we need to identify the horizontal shift of a parabola, and this value is h. Actually, I wanted to go back up a little bit. Okay, there's two different equations that you could have for a quadratic function. You could have the general form of a quadratic, and that's ax squared plus bx plus c. Okay, where a, b, and c are real numbers. We don't want to deal with complex numbers here. The second one is called the standard form, and that's where a is times the quantity of ax minus h, quantity squared, plus k. H and K are your vertex, okay? And notice that H is a negative here, but your vertex is positive, okay? So if we were to look at, we're going to go through this, and then we can figure out different parts of the equation based on what's happened. So here's write an equation of the function of the graph, okay, from this graph. Okay, so we're just going to be reading graphs. You're not going to necessarily be making graphs. Okay, so we're going to read this graph, and we have this here, and we need to find the vertex. Okay, the vertex is the point of change on your graph. So it comes down and then it starts up. So our vertex for this graph is going to be -2, -3. Okay, so I'm going to, so we're going to write that down. Okay, so that's a bit of information that we're going to need. So our vertex for our equation, our vertex is the point -2, -3. Okay, so what we're going to do is we're going to use this, and we're going to put it in the standard form of the function. So h of x equals a times the quantity of x minus h. Let's try that again, not b, but h. X minus h, quantity squared, plus k. Okay, and this right here is hk. Okay, now remember when we were using linear equations, we always had to solve for b. Remember it was y equals mx plus b. We could figure out what m was by rate of change, and then we would use point slope form to find out what b. Well, on this equation, what we need to find out is a using the point. Okay, so now I'm going to go back to that picture of a graph. See if I can find it here. There we go. Now we need to come up with a point that's on the graph. Okay, so here is the vertex, and then I'm going to go along until I can see if I can find a point. Okay, right here we have a point where the graph crosses an intersection on the grid. So this point is 0, -1. So now we know what our point is. Okay. So our point on the graph was 0, -1. Okay. How are we going to use that information? Okay, so we're going to start by putting putting in the h and the k. Okay, so so we have h of x equals, we don't know what a is yet, but we know that x is in -2, because there's our h, quantity squared, plus a -3. And we could rewrite this as just -3. Okay. Now, in order to find out what A is, we're going to put in the points, okay? So we're going to take, so over here, this is our X, and this is our H of X. So what I'm going to do is I'm going to go -1 is my H of X equals A times, then I'm going to put in my 0 for X. Okay, this is +2 quantity squared minus 3. Okay, so we put our point into our equation. Now we're going to solve for A. Okay, so I'm going to use a different color. Okay, we have -1 equals A times X. 0 plus 2 is 2 squared minus 3. Then -1 equals 4A minus 3. Okay, now what I'm going to do is I'm going to add that 3 to both sides. So this is going to become 2 equals 4A. Now I'm going to solve, I'm going to divide by 4. So it's going to give me 1/2 equals A. So now what I'm going to do is I'm going to go back to my equation. Okay, over here, okay, my equation, I'm going to change colors again. Dark green. Okay, so I have H of X equals 1/2 X minus, it becomes out plus, we're going to use this right here, plus 2 quantity squared minus 3. Now, here's the catch. Here's when we look at it as they want us to write the equation in general form. So let's go back up and find general form. That's ax squared plus bx plus c. So that means we have a little bit more work to do. We have to change this so that it's ax plus b. So the general form, let's write that out. Okay, the general form was h of x equals ax squared plus bx plus c. Okay, so we're going to rewrite this. We're going to solve, basically we're going to solve this out so it looks like this. So we have 1/2, and then we have x plus 2 times x plus 2 minus 3. Okay, so then we FOIL that, so it comes out to be, and I'm going to put it in parentheses here as soon as my thing decides to work. Okay, x squared plus, I'm skipping some steps here, folks. I'm making an assumption you can FOIL. Come on. Thank you. Minus 3. Okay, so we've got this far, but we're still not quite there. Okay, so we're going to take, what we're going to do now is I'm going to multiply this times the parentheses. So it's going to be 1/2 x plus 2x. And it's 1/2 x squared plus 2x plus 2 minus 3. And now I have to, it's 1/2 x squared plus 2x minus 1, because I combine those two. So this h of x equals, and so that's our equation, sorry. So that's our final answer right there is our equation. So let's go back here, and we used that graph. So they showed you right here how we did this, and our 1/2 x squared plus 2x plus 1. So the steps that we took was we found our vertex, we put it into our standard form. Okay, remember standard form right here. We put it into standard form, then we used the point that we had on the graph, and so that we can solve for A. We solved for A, Then we wrote it out in this format, and then we went back and looked at our problem and see what form they wanted it in. They wanted it in general form. So all we did was we solved this in the sense that we FOILed our x minus h, multiplied it by our a, and then added our k to get our final answer. So that's how you're going to find your general form for solving when you have a vertex and a point on the graph. Okay.